Good day and welcome to another edition of our tutorial, Mathematics for Machine Learning. Today we'll continue from where we stopped in the last class. Last class we started working with matrix, and basically what we did in last class was we did addition of matrix and multiplication of matrix. So basically, have you ever thought of like something you can multiply a matrix by, then it gives you the same matrix, like beholding yourself in a mirror? Okay, there is actually a matrix that does that, and that's what we call the identity matrix. So identity matrix basically is a matrix that when you multiply a matrix by it, you get the exact matrix you multiplied by it. And how do we get an identity matrix? Okay, an identity matrix is gotten by like this. That's the main diagonal will be 1, and every other row and column will be 0. So we have 0. So here is an identity matrix. Here is an example of an identity matrix. And an identity matrix is always a square matrix. What do I mean by a square matrix? A square matrix is a matrix that has its column and row to be equal. So our rows and column will be equal to one another. So here is an identity matrix, but this one is of dimension 1, 2, 3, 4, 5. That's 5 by 5. So that's on identity matrix. I'll still do some operations with an identity matrix on the long run, but let's move on from there. So the next thing we need to treat now is some properties of our matrices. That's the multiplication of our matrix, some properties that our matrix have. And the first one we'll treat here is associative row. Associative row. Associativity. And what do I mean by associativity? Given for every A element of our m by n, and B element of our n by p, let me still show this part a bit. A times B multiplied by C, where C is an element of what's it called? P by Q. So A multiplied by B multiplied by C is equal to A multiplied by B multiplied by C. So this is what we call associativity. That's when you multiply this by this, then this, it's the same thing as multiplying this by B plus C that you've already multiplied. So that's our first rule. Then we have a second rule that we call distributive. That's distributivity. That's property. Sorry, I said rule. Distributivity. Every matrix actually fulfills this. Once you can multiply them with each other, and you know the rule to multiply two matrices together, as I explained in the last class. So let's move on. So for every A, comma B element of real number m, I said real, the real line, m by n, and C, comma D element of the real line, that's n, comma p. Now we are still talking about distributivity. Then A plus B multiplied by C is equal to AC plus BC. Then A, remember when I was showing us yesterday, I told you A multiplied by B is not the same thing as B multiplied by A. So we are just showing you some basic properties that matrix possess, where you know what you are doing is still right, even if you've done it the other way around, like the way we did associativity the other time. Now we are doing distributivity. So A into C plus D is equal to AC plus AD. If you are in Nigeria, you know a political party called AD. I think they still exist actually. So moving on from there, then we can multiply by an identity matrix. You know, I told you the other time that when you multiply by an identity matrix, you get exactly what you multiply by an identity matrix. So multiplication with the identity matrix. So to multiply with an identity matrix now, for every E element of M, then I M. The reason why we put M here is so that we will have the same number. Remember when I was saying yesterday, the column and row of what you are multiplying by each other must be equal. That's why we put M at the base of A here is equal to A multiplied by I N, which is still the same thing as A. And I will give you an instance why this is true. But note that our IM is not necessarily equal to our IN. That's when M and N, M not equal to N. You know, our identity matrix is always a square matrix, whereas our A, which is a matrix, M might not be equal to N, so it might not be a square matrix. So when it's not a square matrix, then the identity matrix IM will not be equal to the identity matrix IN. But when the M and N are equal, then the two identity matrix will be equal. I don't want to make these tutorials any more longer, but if you are still interested in learning some math today, you can just check the next tutorial, which is about inverse and transpose. So see you in the next lecture. Thank you.